record, remember screen sharing. Okay. Now we've got a full class. We're in here from this week onwards. I'm sorry about all the room movements. There's a few classes in the course that were in like lecture theatres, which I wasn't very happy with because we do lots of sort of interactive exercises like the one we just did. So we'll be in a nice classroom now. Let's start. What's the difference between super and this? And just using this as an example, talk about the concept. Does anyone want to check this out? Yep.
Super refers to the parent object.
Mm-hmm.
Well, this refers to the current object. That's the class.
Yeah, I think you've summed it up nicely. Do I have a whiteboard marker? Whiteboard. So actually, I'll use this. Oh my god, that's very disgusting. So when you have an object, and we think about this idea of inheritance, right? Where you can say, well, you know, maybe I'm a dog, right? But then I can also be an animal. And animal encompasses a whole lot of stuff, right? Dogs, cats, you know, any sort of animal. And we go from abstract to concrete, or general to specific, however you like to think of it, when we go down the inheritance hierarchy. But we say that a dog has all the properties of an animal. And so because of that, when we get into object land, we can talk about this idea of super, which says, I'm referring to the parent object. What does that mean, though, parent object? Like, you know, if you create a dog, I say dog D equals new dog. It's like, I've made a dog there. I haven't made an animal. So why do we have this idea of a parent object? Anyone want to think of this? Yep.
Because when you create it,
Yeah, exactly. It's all the properties of an animal. What does that mean? If you think back to last week, we talked about memory and struct stuff, right? What does that mean sort of in real talk? Yeah.
So in memory, you must store the animal part, like here,
Hang on. David, right? Yeah. So David's, I don't know exactly how it's implemented in memory, but we don't have to worry about it too much. And the main idea is conceptual, where, you know, here's our object memory, right? It's a 4x4, 16 bytes worth of stuff, probably more than that in real life. But let's say the first 8 bytes are animal. And then, you know, you've got some animal fields here and some properties, blah, blah, blah. And then the next, let's say, I don't know, 4 bytes, let's say the rest of the object is dog specific stuff. So when we kind of talk about super, you can think of it as referring to this bit of memory here. Now, I'm not going to go into the specifics on how it actually works, but think of it that as a conceptual level. Okay, so that's super. You talk about the parent, and getting on to, oh, actually, I won't get to that yet. What about this? And I think your name, Williams, yeah, Williams said it before. We talked about the idea of the current object, and you can think of this as being me in a sense. So remember, what is this actually? Again, talking in memory speak. Anyone want to take a guess? We talk about this referring to the current object, and we can access properties, fields, methods. So what might it be? It's a dog, but what is it under the surface? Yeah.
just the instance variables.
Yeah, well, it gives us access to the instance variables via some sort of starts with P.
The dog only dog has, but not only for all the animals.
Yeah, all the specific stuff. Yeah. It's a pointer. Thank you. So when we say this, oh, where's my mouse gone? This name, we're calling the constructor in this case. That's a bad example. We say this dot width equals width. We're saying this object has a width property, and you can think of it like literally like a struct access, and we're going to set that property to be the given width. We talked about that last week with construction and fields and that sort of thing. Okay, so this is the current object. You know, if you make a new dog, as Sonny said before, it's this dog D here. If we make a dog D2, this is D2, and this is obviously can't talk tonight. Very sad. This is obviously specific to each individual instance of a class. All right. What about question 2? What are super and this? Same ideas, but what are we talking about specifically? Yeah. Constructors. Yeah. So we're calling the parent constructor here, and we're calling our own constructor. Now, what does that mean? We're doing recursion here. Like, what do we mean by calling our own constructor?
Supers is like the attributes of the parent class, while this would be calling the,
That's okay. Is what you notice with the rectangle class is we have the same method defined twice. Does anyone know what this is called? Yeah, method overloading. So in Java, there's this idea that you could have a function which is defined more than once. And each definition of the function takes different inputs. And you couldn't have this be, oh, you know, we're going to define public rectangle string color and then another public rectangle string color. That wouldn't work. Let me show the code actually. We can start to. Oh, no, I'm still frozen. That's all right. You have to have different method prototypes or signatures. Okay. Now, when we say this name, what function are we calling? Someone else? Yep. We're calling this function here. And what we're doing is we're just piggybacking off another overload of the same method. So rather than repeating ourselves, because we'd say, you know, what we say? We say this dot name equals, oh, hang on, sorry. We'd say this dot, no, we can't even do that because it's stored in the parent class. Never mind. The point is, rather than setting it manually, we say, well, we've already got this code somewhere else. So we're going to siphon that off to the other method that's already doing it, avoid repeating ourselves. Now, this one goes, I'm going to actually siphon that off to the parent class, and it can be the parent class's job to do it. We'll talk more about that in a second. I think let's move on to the next exercise. So I'm going to unfreeze. Oh, sorry, I was highlighting and that didn't work. Sorry, just bear with me. Okay. Let's talk about access modifiers next. Should we do? Does anyone know what the form access modifiers are in Java? Yep. Yep, public, private, protected, and default. Okay. Starting with public, what do each of these mean?
It just means it's available with everything in the same. I know, not packaged, but everywhere.
Yeah, it's almost, you could say, globally available. That's right. Sorry, I'm just going to change something for 1 second. Feel free to talk amongst yourselves. We might make this shoot a bit longer just because we've got a lot to cover, and I messed something up with the organization, so I'm just going to fix that up quickly. What was the name again? Oh, Ife, yeah, thanks. I'll just write that down. Okay, here we go. I'm very sorry about my lack of organization tonight. Oopsie, that's not what I want. Go back to README. Let's go back to talking about access modifiers. So we've got public. Now let's go to the other end. What do we have? What's the opposite of public? Private. Okay, what does private mean? Yep, Rhythm. Sorry? Can you use it in the class? Can you use it outside the class? Can you use it in a child class?
Yeah.
You sure? So this is a common gotcha. Sorry, I'm just figuring out the Zoom. I don't know where my Zoom's gone. Oh, here it is. I'm gonna go back to sharing VS Code. I'm still working out this recording thing. It's a little bit new. Okay, let's do this one actually. So we have an int there, which is this is going to be default. This would be the same as we said default out the front. We've got public, protected, and private. Now we have this method A. Okay, if we try to B extends A, all right, let's what should we do? Split right, so we can see both at the same time. Now you think, well, let's see if we can access a private variable of A inside B. So our private variable is called varpriv. And if we try to uncomment this line, you'll see that we have a problem here. The field a.varpriv is not visible. Now, VS Code knows that it exists because we've declared it up there, but it's saying, well, you don't have access to it as a child class. Now, why might that be the case? You think it's a child class. Shouldn't it be able to access the internals of its parent? Anyone got any idea what the purpose of that might be? Yep.
It's just so you can't just, you can't just,
Yeah, and you're on the right track.
you can't just like change it. This sorry,
No, you're completely right.
so like security.
Yeah, so I think I would say more safety than security, but essentially, like it kind of brings up to the question of why do we even have these access modifiers? What's the point of making something private or public? Because you're the programmer, right? You should be able to do the right thing. So the term is kind of comes down more to software safety, which is you as a programmer have a potential to mess things up. And does anyone know why we would make stuff private at all?
Prevent access from outside fields.
Yeah, but why do we want that?
So like, not if it would be like information.
Yeah, that's true. So yeah, we're going to need to modify it in a way that you as the class writer describe. I think that's on the right track to what I'm getting at. Anything else? Yeah.
So,
Yes.
like, for example, if someone else has to change when you change an attribute, then you can ensure that that happens if you need that to the site.
Yeah, exactly. So if let's say, and you can apply this to a lot of ideas where you have some data, right? Here's some data, and it's publicly available. And then here's another program that says, okay, well, I'm going to use this, let's say this is a class or it's an API or something. Same thing, an ADT. And then, you've got this client, and when I say client, I mean, you could be a command line wrapper, you could be a server, you could be a front end, you could be some tests. And tests is probably the easiest sort of analogy, where it's like, okay, maybe I've got some tests. And I'm going to test the class, and I'm going to do it by saying, you know, like maybe you've got X and Y and Z here. I'll say, you know, function one, assert, and we've got this, you know, object. Then we say assert object dot X equals 1 or something, and then object dot Y equals 2, blah, blah, blah. What have we done here when we've started to access the internals of the class? We've created coupling, which is if we decide, oh, you know, I actually don't want it to be X and Y, I want it to be A and B, or you completely change the internals of the class, what's going to happen to these tests? I can hear you saying they're going to break. Yeah, they're going to fail. And then you have to go change the test. And that's because these two things are too tightly coupled. And what you want to do is instead of accessing the data inside the class, we want to access it via some sort of interface. I'll do that in another color, actually. We want to access it via some sort of interface, which is our getters and setters, as someone says before. And the reason for that is, so long as the interface stays the same, you can change the internals as much as you like. You can do whatever you want. And the test won't break, or the server won't break, or whatever. Some other layer, some sort of client that relies on your class is not coupled to its implementation. And this is a really key idea. So this is what we call encapsulation, where we actually enforce the privacy of the data. So this is all private. And the data is interacted with through the functions. And then the client interacts with the functions. They never actually look at the data themselves. They can't see fields that are private. Does that make sense? Okay. And you have been doing this for quite a while. Maybe without even knowing it, this is what black boxes are, right? When you think of black box testing, it's like you write your tests to the functions, not, you know, you don't go and access the data store because, you know, who knows how the data store could work underneath. So that was some stuff on encapsulation. And now we're going to actually write some code now that we've got a working editor. So what we're going to do is within the source directory, create a new package called employee. So when working with VS Code, I can make packages on the fly like this. And you will generally want to structure your code into packages in some shape or form. And you want to do it in some sort of logical, conceptual way. And I would highly recommend for the assignment that you create subfolders to group similarly kind of similar entities or classes together. So we've got this package called employee, and within it, we're going to create a new class called employee.java. And I'm going to move this over here. Okay, so create an employee class which has private fields for employees' name and salary and appropriate getters, setters, and constructors. Document the class with JavaDoc. Now, I could do this all by hand. It would probably take me about 5 minutes. You'd sit there and watch me code, and it'd be really boring. Or we can use VS Code, because this isn't just a text editor, right? This is an IDE, and it's a piece of software designed by software engineers for software engineers to make writing code easier and to take out boilerplate. So what we're going to do is we have to say what the internals of the class are first. So we'll say private string name, and then we're going to say private. What do we have? Salary. Private int salary. And I think that's it. And now what we're going to do is, instead of going and making the constructor and the blah, 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 like we did last week, we're going to go right click, source action, and we're going to generate a constructor. And we want both of those fields. We hit OK. Bam. Does it for us. And it gets even better. We can do that again. We're going to go source action, generate getters and setters. We're going to click both. Yep, we want a getter and a setter for both. We hit OK, and bam. All that boilerplate done for us. Very useful. And now we're going to document this class with JavaDoc. Now to create a JavaDoc comment, we go we go slash and then double star, and it will say, do you want a JavaDoc comment? We hit enter, as a way of saying yes. Now, does anyone know what JavaDoc is? Yep. Commenting in Java? Yep. Any expansions on that? Yep. Documentation, for sure. Yep. Yeah, gives you easy access. And when we say easy access, like if you hover over string, right, it gives you this whole little snippet. It says this is what a string is, this is what it's about, here are some examples, blah, blah, blah. And the way that's actually generated is through JavaDoc. So if we go to definition, you'll see that here is everything we just hovered over. It's just like some HTML. It doesn't look very pretty here, but when we use it in our IDE, it gives us this nice representation. So we can make that for our own classes with JavaDoc. So that's what these @param things mean. It says, you know, here's a parameter and name of the employee and salary. And, you know, constructor. And so now if I go public static void main string args and say employee e I can hover over that and it tells me what I just wrote. So that's what JavaDoc does. Now, if you want to document a getter like this, you can do the same thing. And you can see that it will say, well, this is what the function returns. So I'm going to return name of employee. And you get the idea for set name and set salary. I'm not going to do it for everything. So that's JavaDoc. And I think in one of the labs this week, we asked you to document the class with JavaDoc. Now, something that we changed this term is we're not going to make you do JavaDoc for everything because it's a bit of a pain. And it also touches on this idea of, you know, what value do comments add? Like if you read this, is the comment, right? The bit that's not string name or, you know, param name. Is that telling me anything I don't already know? Not really. And, you know, like what if, let's say we have a, function here that's like, oh, I'm trying to think of a good example. Let's say we decide to add in another parameter and we say, you know, we've got string name, salary, and local date, start date. We just need to import that. Now our comment is out of date, right? Because we've introduced this new parameter, but it's not in the documentation. Or maybe we actually take out the salary and say, now there's just, you know, now there's just a start date. But the comment's out of date. So this is what we call comments going stale. And that's why we can consider them being a code smell. The other thing is what you sort of really want, and this sort of alludes to what we were just saying, is that, you know, for someone, like, what are the purpose of comments? Just in general. Yeah, Sonny? Yeah, or even to help you later when you've completely forgotten about the code you wrote 6 months ago and are looking back at it and going, I don't understand what that code is doing. You know, it gives you, it helps someone who's unfamiliar with the code understand it. But the problem with that is that if your code is so not understandable that someone needs to explain it to you, then is it good code? Probably not. Now, I say this with a grain of salt because at work, I deal with a lot of code I haven't written, right? You know, we work on these big systems that have been worked on by people 5 years ago and people in the team currently and stuff. And even though the code's well written, it's still hard to understand. Why might that be? Yeah.
The description of a lot of stuff being reported from various places. There's a lot of complications. still make these other parts or understand. Just if it isn't in very high level, it's hard to know what it was.
Yeah, I think we've touched on a few things. So like dependencies and assumptions. Those are two really big things where, you know, it's sometimes you look at a piece of code, you go, I don't understand how this really works, but then you realize there's some other piece of code that's referencing that is the reason it works. And you see the reference and go, oh, okay, now I understand. That's what import statements are really good for. You go, oh, okay, well, this relies on the local date object. And sometimes code will just make assumptions, right? Preconditions and postconditions. We'll talk about that later with design by contract, but they need to be documented as well. So this is not to say that, you know, all comments are bad. Another one is just sort of, if you're not familiar with, if you're new to the language, like a lot of you are new to Java, and sometimes like this code's pretty readable because it's very self-explanatory, but something that's a bit more complicated might be a bit harder to understand. So that's just a, you know, programmer's familiarity with the language. And then the other thing is familiarity with the domain. So for me at work is, you know, I don't fully understand, like I deal with a lot of code that's to do with assets and articles and posts, and, you know, these are all sort of like entities in your domain model, which you're kind of going to be doing for the assignment with satellites and devices. And if you don't fully understand the model, then it's hard to understand the code. And this isn't very true of any sort of object-oriented or sort of large-scale programs that deal with things that map to the real world. So that's kind of my 3 cents on comments. For the course, we're not going to make you do JavaDoc on anything past that lab where we get you to just do a bit of practice to gain familiarity. In terms of writing comments, like some people in their assignments like to do stuff like this, where it's like, oh, you know, here's set name. That's the name to be the given name. Now, is that a helpful comment? No. So really, your code should be so self-documenting that you don't need any of this. In fact, you would try to have it as your goal that you don't write any comments at all in your code. You might have some like JavaDoc, which is, you know, specific stuff to, you know, help with the, like this rendering stuff for someone who's using your class. But in the actual internals of the code, you don't need to explain it to the reader. I see a lot of people in like the first year courses and they have lots of comments that explain their code. And it's like, I don't need your comments. I can read your code. I know how to code. Someone who doesn't know how to code won't be able to read it. But that's not the problem, right? They just need to learn to code. So that's just turned into a rant from me about comments. But does everyone get the general idea? Put up your hand if you're a pro comments person. You think comments in code are good. I'm not going to judge anyone in their opinions. Put your hand up if you think comments are bad. Inherently evil. Put your hand up if you think, you know, they're kind of useful in some situations, but should be used cautiously. Okay, cool. Are there any questions on any of that? Awesome. Let's crack on. We're going to keep going and talk more about inheritance. So we're going to, how many constructors? Oh, okay, sure. So this question, how many constructors should the class have? How many arguments should they take? Now I'm going to go back here. I feel like this question is missing something. I'm not sure if it is. How many constructors should the class have? What arguments should they take? Okay, let's skip over that one. We might come back to it at the end. We're now going to create a manager class that is a subclass of employee and has a field for the manager's hire date. I think, okay, that's fine. Why do we get an error here? Refers to the missing type local date. Just going to go back. There we go. So we're going to call this manager.java, and we'll say manager, what keyword? Extends, yeah. Employee. Now, you see, implicit superconstructor is undefined, must define an explicit constructor. Does anyone know what this refers to? Yeah, so when when we have we create a subclass, for most, like we could have this empty class here. Nothing's inside it. We just have this idea of a manager, but it doesn't contain any data. It doesn't contain any functionality. It's literally just an empty object, an empty class. However, sorry, and as part of that, you know, it's going to inherit all of these methods, all of these getters and setters. So if you create a manager, you'll be able to do all this stuff here. However, Java requires that every object with a constructor, if you inherit that class, that subclass also has a constructor, even if all it does is just say palm it off to the parent. So what I'm going to do is I'm going to go command dot and say add constructor. And all this does is just say, okay, I'm given a name and a salary, and I'm just going to call the parent constructor, right? And we're familiar with this from the first exercise, right? Now, if we wanted to do more stuff, so now what we're going to say is, we're going to have a field for hire dates. We'll say local date, hire date. And we'll say private local date, hire date. Just need to import that. Are we done? No? What are we missing? Yeah. This dot hire date equals hire date. Because even though we've said, okay, we've delegated the name and the salary to the parent constructor, we still need to deal with this new parameter that we're given. So we say, okay, everything else that's already covered for in the parent class, you go up to the parent class and do your stuff there, and then we'll make our own, we'll bind this piece of data that we're given to our internals. Now, all right, what constructors are appropriate? Is it appropriate to have a getter for the hire date? What about a setter? What do we think for this one? Is it appropriate to have a getter for the hire date? What about a setter? So is a getter useful? Yeah, okay, let's make one. Let's make both actually. So we'll go right click, source action, generate getters and setters. And because there's only one field, we don't even need to check the boxes. It just says, well, I'm going to make it for this one field here. So you think, yeah, that makes sense. I want to get the date they were hired, but why would this not make sense? Yeah, it's like once you hire someone, you've hired them, right? Their hire date doesn't change. That being said, though, in real world systems, I feel like this would, you know, conceptually would still be a thing. You know, your hire date isn't read only after you've written them because, you know, maybe you put in the wrong date or something. So it all depends on the context. Now, I just want to go back to, because we were talking about encapsulation before, and we talked about this idea of, you know, keeping stuff private. We never talked really about why it's important that the stuff in the child class can't access what's in the parent. So does anyone want to, you know, given all the stuff we talked about here, want to take a guess at that? If I say, like, let's say make this field public, and for some reason in the constructor, I'm going to go, well, this dot name equals manager plus this dot name. So it'll just prefix the string with the string manager. Now that seems fine, but we have a risk of doing something in the subclass that would actually break what's in the superclass. And there might be some sort of semantic conditions around this piece of data here. In this class, there's none. When we get to week 4, we'll talk about the Liskov substitution principle, which says if you are a subclass, I need to get this the right way around. Yeah, if you're a subclass, you should be substitutable for the base class, and you shouldn't accidentally break something that's in the base class. So that is a kind of a bit of a teaser for that when we get to it in week 4. And that's part of why we keep data private from child classes. Okay, we'll get rid of that and we'll go back to here. So now all these questions about what constructors are appropriate, these really come down to what semantics are going on in the problem, right? Like if in this case we have a manager, and you know, it's like, name, salary, hire date, they're all bits of relevant information. But let's say you had some sort of field like their bonus, right? Actually, I'll put it over here. You know, so you've got this manager and they've got a bonus, they've got a base salary, they've got their like number of days of leave or something. Days of leave. And then, you know, maybe in this company that we work at, some managers start with a bonus and some don't. And so, you know, you could either have a manager that's like new manager, name, blah, 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 and a bonus, or new manager, name, blah, 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 and then nothing. So there's different ways of creating the object. This is a very, you know, siloed, baked up example. So it's really hard to say what constructors would be appropriate. But again, you have to think about the context, think about how will someone use this object? How will a client, whether that's tests, server layer, whatever you might be using, how will that construct objects? And you want to avoid doing things like, oh, well, I'm going to just pass in like null here as a default value. That's a bad design because you're, you know, kind of making it fit the constructor rather than just having a constructor that fits the actual use case. All right. Is it appropriate to have a getter? We did that one. And then override the toString method inherited from object in both classes. Okay. So now what we're going to do is we're going to go right click, source action, our good friend, and we're going to generate a toString. And we want one for the hire date. Oh, this is very kind. So this, you know, we could type this out, but what this does anyone know what toString does? I want to have heard from. Like everyone's there. Yeah, sure. Yeah, can you begin or are you stretching? Okay. Yeah, it's a really good definition. It's a sort of textual representation of the object. So if we say public static void main and make a new manager, blah, 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 and local date dot of 1, 2, 3, 4, 5. What does that work? Year, month, day of month. Okay, cool. And then we're going to say system.out.println m. Very exciting. We're running code for the first time in Tute this week. Oh dear. Need to put this back. We're going to run that. It prints out this string. So when we call the print function, it's going to implicitly call this toString method. And we could do it explicitly as well. We could say m.toString. We run it again, it'll give us the same thing. So sometimes we'll want a sort of string representation of an object. That can be really helpful when you're exporting the object or trying to like serialize it into JSON or some sort of persistent layer. It's good for debugging purposes as well. Probably debugging is the best use case, I would say. And yeah, we asked you to do it as part of lab 2. Now, the bigger question is, well, what if we didn't have a toString method? What would it print then? Does anyone know what it might do? Yep. Yeah, it's either the hash code or the address. I can't remember which. Yeah, so we've got employee.manager, the name of the package and the name of the class, and then at 2D blah, blah, blah. I think that might be the hash code. Let's print out the hash code. The hash code is just like are you guys familiar with the idea of a hash? Some are, yeah. It's just sort of a string of numbers, which is created by this object, and I don't know how it's implemented. So m.hashcode. Oh, I see, it's an int. I think in this case, this is just like an int written in base 16. Yeah, so this is just like a number which this object corresponds to. If I make a new manager, call that M2, and then I'm going to say print M2.hashcode, the number will be completely different. Sorry, M2.hashcode. Cool. Yep, completely different number. Now, one really important thing is the equals method, which we're going to override next. So we'll keep this back. And then I'm going to go right click, source action. We're going to generate hash code and equals. Sure. We've got one for the hire date. Ooh, that's a bit disgusting. Let's do it in the superclass actually, because that's a good starting point. So the idea is if I'm given 2 employees, E1 and E2, right, these are the same conceptually. They have all the same information. And let's say if all these 2 bits of information are the same for 2 given employees, their name and their salary, then we can treat them as the same thing. But if I say print system.out.print line, E equals E2, it's going to say false. Okay, why might that be? It's not comparing the hash field, it's comparing the addresses. So this here, and this is really important because not everyone, but a lot of people get this wrong for the assignment, is this is just a pointer comparison, right? Because you've got 2 objects and everything's just a pointer in Java, except for the primitive types. These are just comparing the addresses because object-oriented programming, semantically, Java doesn't think, well, this equals actually calls a function. It just does the raw compare 2 pointers that you would in C. If we want to do something, that has sort of meaning or isn't just a primitive operation, we need to do it via a method of a class. So this is, and the reason I say that is because, in Python, when you're like Python 3, let's say like A equals A, that says true. These aren't characters, these are strings, right? But they live in 2 different areas of memory. And Python goes, well, I know what you mean by equals. There's this semantic attached to it, which says, equals for 2 strings means you check each of the characters and check if they're the same. This is what we call operator overloading. Used in Python, used in C++. Java doesn't support operator overloading because one of the ideas is that, this is a primitive operation. This doesn't have some sort of special meaning attached to it. So anyway, we'll say system.out blah blah blah. Print E dot equals E2. And so we'll run that. Now that still says false. Why does it say false? We're calling the equals method. Sorry? Yeah, so at the moment it's still using the default implementation of equals, which is the same as the pointer comparison. So what we need to do is override it. So we're going to go source action. We're going to stay a bit longer, so don't pack up just yet. So there's some stuff I want to talk about that will help you to the lab, which will eat into the lab time a bit, but I think is worth it. So this is a bit ugly. I'm going to get rid of the hash code. This is how the hash code is generated, just out of interest. We can take a break in a second as well. And I just don't like how this is formatted, so we're going to do it from scratch. The first thing we're going to say to check if 2 objects equal, and notice that you don't get given an employee here, you get given an object. So this could be anything. This could be a string, this could be a local date, time, whatever. First thing we're going to do is say, well, if the pointers are the same, right? So we say if this equals object, then are they going to be the same thing? Yes. So we're going to return true straight away, because if you do something like, E dot equals E, this should be true. And we know it's true. We don't even have to look at any of the fields because the pointers are the same, because they're literally the same variable. So okay, that's the first thing. Then the next thing is, well, if they're not of the same type, then we know they're not equal. Pretty straightforward. So we'll say if get class not equals object dot get class, return false. Now, there's another way I could do this. I could say if not object instance of employee, return false. Do these do the, sorry, I just need to wrap this in a parentheses. Do these two do the same thing? Who thinks yes? Put your hand up. Who thinks no? Who doesn't know? There's like 10 of you just didn't put your hand up at all. Okay, so get class, what does it do? It returns this class object. That's really strange. We can talk about that in future weeks once we understand kind of OO a bit better. But the difference between these two is one says, you know, if I'm, let's say I'm an employee. So we've got E and then we've got a manager M, which is our subclass we've created. E is employee. What is this going to return? If I say M instance of employee, is this going to be true or false? Who reckons true? Put your hand up. Who reckons false? Okay, I'm going to do this again. Please, can everyone at least put their hand up once? Who reckons true? Who reckons false? Okay, it's going to be true because what do we know? Well, if you're a manager, manager extends employee. That's what we said here, which means that everything a manager is, you know, we said this before with our little triangle. A manager is an employee conceptually. An instance of captures that. So you could be a manager, but not an employee and pass this. Does that make sense? So we want to actually check if the classes of the same type, which is what this get class function does. So if you have a manager and employee, and we say, okay, get class will be what? What will this be in all cases? Employee, yep. And this one will be whatever the object is, you know, it could be string, could be whatever. And this, if this is a manager, it will return false. So that's the long-winded explanation of that. Okay, so now we know they're of the same type. We've gotten that far. So we need to say, okay, well, I need a way to check the fields because that's what, you know, that's what we're trying to do here. We want to say that E and E2 are the same. So we need to do a typecast. We'll say employee E equals employee object. Right, and you're familiar with this idea from C where you can say, okay, I know, and you can do this safely, right? Because if you didn't check the type before, that'd be an unsafe operation because you could cast, you know, the object could be anything, right? You could be casting a string to an employee and that wouldn't work. Whereas you've checked the type here, so you can say definitively, and this comes back to the safety idea we were talking about before, this thing is employee. Yes,
We check for null objects.
oh yeah, we do. That's a great point. We should have done that here. So say if, what do we say? Yep. And what we do? Why? Yes, but what if the employee is null? What if the employee is null? That's my question. You can't, because it's null, right? It's not a pointer to an employee which has this equals method. If you say null dot equals something, then it'll go, well, you're null. It gets a null pointer exception. Does that make sense? Yep. Cool. So we typecast it to an object. Thanks for picking that, by the way. And then now we can say, okay, we can actually look inside the class. Now here's an interesting bit. We're going to say if e.name, we've got to use it this properly. So say e.name, no, hang on. Yeah. not e.name dot equals this dot name, or not, I think I need to wrap this again. Yep. E dot salary. Oh, and now we can just say not equals because these are primitives, right? These are integers. This dot salary. Return false. And then we know that all the data is the same, so we can return true. Is there anything funny about what I've just done there? Yeah. I have, but is this a recursive equals or is this something else? I've just given it away. It's not the original equals, but it's the equals that belongs to what class? String. So this is the equals that belongs to employee, which means that when I say if not e.name.equals, I'm not calling this method I've just written again. I'm saying, okay, now I just want to compare the string, right? And it's going to do the string equals, whereas we're in the employee equals. Make sense? Okay. Sorry, I said I'd give you a break. And we'll do that right now because we're probably going to run into about 20 past, just extra stuff to talk about. So you can have a 2 or 3 minute break. Stretch your legs, go to the bathroom, do what you need to do. Yep. It's unusual to 6 o'clock at night, including me. So I feel like we need to have like a start of class or something. You can actually do that one. That'd be really fun. 15 coffee. Is it easy to make coffee? Yeah. We should do that one.
Hello.
Yes. Yes. It got moved here for this week. Oh no. All right. We'll move.
This one. No, come on. Let me see if there's another one.
Okay, thank you. Oh, just now, get out of my classroom. Oh, yeah. Sorry. The problem with the lab is like it's really hard to do this sort of thing in the lab. You know, like everybody's using their computers. And you can't. So I'd rather do it here. Wait a minute or so to see if we can there. Yeah. Because we want to be able to access the key so the object, right?
Isn't that what you check?
Yes, but all that tells us is the class of the object in terms of, like you have this you have this bit of memory, and this could be anything. It could be string, it could be math, it could be whatever. And there's a bit in here that says no, I'm actually an employee. Okay. But Java doesn't know that. Or we've just checked that by calling this function. But to Java, it's just still an object because that is the type of the variable. So, and because anything's an object, right? You know, our employee extends object.
So even after we check if it's a get class with the get class function,
yeah,
you still have to change it from an object to an include.
Yes, and
that's what, so you're going down.
Yeah, exactly. So we're what we call downcasting. That's a really good point actually, because you can have an object, right? This is the
Right,
and then you can have superclass, and then you have a subclass. And
okay, so it's like even if it's for example, like you have an employee, which is what you're checking against, and then object is even if object is like something above employee, like a superclass of employee, that'd be still the same thing, right?
Yeah, so like it's all the same memory, right? It's just how we're treating it, how we're looking at it. It's like I can look at you and you're a student, but you're also a bunch of organs, but you're the same thing.
Okay. Also, it's just how we look at it.
Exactly. So when we cast something, we're just saying, okay, now I'm going to treat this as an employee.
Also, we only do that. Think of it within the realm of employees.
Yeah.
But in line 53, it's thinking of it as object or whatever it is.
Yeah. Exactly.
Oh, so it's like going more specifically to employee.
Yes. And we can only do that because we check the type. If we didn't have that, then we couldn't do that. That wouldn't be a safe operation.
Right.
Because it's like you could be casting down from object to think, but this is actually a string.
Or object could be something that's a subclass of employee, and that would work.
So that would work. You could say, like, you could have a manager and you could cast that to an employee because an employee, sorry,
Oh, yeah.
because manager is an employee. But in our, we still return false there because semantically it doesn't make sense.
Oh, yeah, and also we have to make sure that we only think of that as an employee as well.
Yeah, exactly. Because you're not checking if it's manager, you're checking if it's an employee.
Okay.
Good question. Yeah, it's does anyone have any more questions on this? Because sorry, I forgot to- Richard asked some really good questions about the internal of this method. So what happens here in this line 56 is we go from general to specific. Think about triangle again. We go from object to employee. Because all the memory is all the same, right? The memory doesn't change. It's just how we're perceiving it or how Java is perceiving it. And as I said to Richard before, it's like, you're a student at UNSW, but you're also a bunch of cells and you're also a bunch of atoms, right? And we're just perceiving it at different levels of abstraction. It's the same thing here. And as I said before, we can only do this safely when we know the type from this if statement. Okay. Oh yeah.
If you extend employee to manager, and since we manage take this equals,
Yes.
so in that case, when you do get false, will you return manager?
Yeah. So we'll try and do the next one because I think that will the next part will answer your question. Yeah. Well. Yeah. So if I deleted this and change this to object, the problem is it says name cannot be resolved or is not a field because even though this object has a name, Java doesn't know that, right? It's like if I say example. So it's more general. So it's like saying, I know that you're a student at UNSW, but I don't know that you are doing COMP2511. So I can't say, like, what was your mark in the assignment, right? Because it's like, well, how do I know that you know that you're doing 2511? Whereas if I do that check, if I say, well, if I know that I'm an object of this type, because get class is matching, then I have to say, okay, now I'm going to go down the pyramid and treat you as a student of 2511, or treat you as an employee in this case. Does that make sense? Yeah. Now, my question from before, what's kind of weird about this line? And this goes back to the encapsulation stuff we're talking about before. You notice that we say e.name.equals. So we're accessing the name of this object. We could also say e.getName, right? Is there one that's better? GetName, maybe. I actually don't really have an opinion on this. I think it's fine because, and the reason is, we're not breaking encapsulation here because we're inside the employee class. We've got two employees. And it's like, you're like me. I know you. I can access your internal, right? So this is an okay time to access the fields of another object because we're actually inside the same definition. Does that sort of click? Cool. All right. We have so much. The thing with this point of the course is like we just have all this stuff to talk about and all this stuff to sort of conceptualize. So I can talk for hours, but let's do the subclass because that should be quick, and then we'll talk briefly about exceptions because you wanted that, right, Sam? And I'll talk very briefly about interfaces and abstract classes. So we're going to say override, we'll do this manually. Public boolean equals object. Now, the bulk of the work has already been done in the superclass, right? Because this is boilerplate. This is, check if it's the same pointer, check if it's null, check the get class, and check the fields. And we, if we're a manager, we still have those fields, salary and name. So we still want those to be checked for it to be considered the same thing. Which means that really, I could just say, if not stupid not operator, super dot equals the object, return false, right? And now most of the stuff's already been done because we've done the null check, we've done the pointer check. And what's get class going to be in this case? When we're calling it from the manager? Is it going to be manager or employee? Who reckons manager? Who reckons employee? No one. It's going to be manager because, again, even though we're inside the employee class, this method is specific to the manager object, right? We're calling this from a manager. And so get class will return manager. And if this isn't true, if this is an employee or something else that's not a manager, then it will return false. So we've already done this check, which means that we can do our typecast. We can say manager m equals manager object. And then we can, now do we need to check all of the fields? And we can't, can we? Because they're private, right? So we just need to say return m dot hire date dot equals hire date. And that's it. We could even change this just to say return as well. I was talking with someone on the forum about this earlier. Does this make sense to everyone? Right? Because this is just going to be a boolean, right? It's evaluated by true or false. And then instead of saying if blah return true, else return false, we just say return blah. Everyone happy with that? Cool. Okay. Okay, exceptions. Did you have any particular question, or do you just want me to sort of run through them generally?
No, I think we wanted to.
Yep. Yeah. Okay. What we'll do is in source, make a new folder called exceptions. So here's our checked example. Actually, we'll do it. Okay, so we're going to say this extends exception, and we're going to say no, sorry, this is going to extend runtime exception. So this is what we call an unchecked exception, and we have a main method here. And if I say throw new checked example, you notice that I don't have to wrap this in anything. I can just run this and it'll throw an exception, it'll spit the dummy, but Java doesn't really care from a compilation point of view. Whereas if I say this just extends regular old exception, I think there might be another class, I don't remember what it's called. It'll say, hang on, you haven't handled this exception. What are you doing? You're just going to let your code run away like that. So that's the difference between checked and unchecked, is whether or not Java controls about full handle. And there's different types of checked and unchecked exceptions which relate to, so things like file, if you have code that opens a file, you always need to wrap that in a try catch, because what if the file doesn't open, right? Probably things like Python, where it just fails and then your code's broken. Whereas in Java, there's no, you actually need to handle this yourself as a programmer. Whereas other sorts of exceptions, they you don't have to worry about that. And these are those runtime exceptions. Does that make sense? Cool. That's a very surface level overview, but I think the lecture goes into a good amount of depth on that topic. So the last thing I want to talk about is interfaces versus abstract classes. So I'm going to call this animal.java, and it's going to be an interface. Oh, sorry, that's a very bad package name. I'm going to change this. Does anyone know the difference between these two things? You can think of an interface as like a .h file. So, you know, we have a public void make noise or something. These are very silly examples, but you get the idea, you know, public void eat. And I can't write any actual code. You see here, abstract methods do not specify a body. And you can think of this as being like a .h file. So for any time when you want to model a behavior, and we'll talk about this more next week, but anytime where you want to model a behavior or have some sort of functionality that maybe it's different for each kind of implementation, but at a high level it's the same, you use an interface. And then abstract classes are really good. I'm just going to do it in the same file. We'll say abstract class animal, and I'll comment this out so it doesn't complain, and make this public. And in an abstract class, I can actually have implementation. So maybe we have, you know, public void make noise, and it's like return, or I am making the noise. And then we can also say, well, actually, we also have this behavior called eat, but we're not going to define it. We're going to leave it to the child classes to define. So we mark this as abstract. Now, a key thing with an abstract class is you can't make an instance of it. And the same thing, you can't make an instance of an interface, right? Because there's an interface is literally just like a how do I describe it? It's like a sheet, if you will. You know, it's just like a curtain because there's no actual implementation behind it. So if I go main and then say animal A equals new animal, this is going to yell at me because it cannot instantiate the type animal. And we use abstract classes to model things where the type literally is too abstract, right? You know, like what's an animal? An animal is going to be a cat or a dog or a mouse or something, right? It's not just going to be an animal. Whereas if you have, for instance, an employee, right? You could just be a regular old employee, but then you could be a manager. The manager is also an employee, but employees still exist. So you get like a hierarchy, whereas here you have that hierarchy, but there's no such thing as just an animal. So this all comes down to the semantics and the conceptual sort of element of it, where it's like, what does this, you know, correspond to in the real world? And next week, when we do domain modeling, we'll see an example of that where we think, okay, we're going to use an abstract class here and we're going to use an interface here. But because it's helpful in Lab 2, I thought I'd talk about it very briefly. Okay, this went on for a while. Normally the Tute won't go this long, but I think, again, let's talk about. Is there any questions on anything we've covered today? No? You're all tired? I'm getting quite tired, to be honest. So we'll go for a nice walk, get the blood pumping, and I'll see you all in the lab.